is the third and final review for the exam 2 for Chem 111. The first thing we're going to discuss is the percent composition. Now this is a percent by mass, and we do this by using the molar mass. So before we do anything at all, we need to figure out the molar mass of KNO3. So K, N, and O, we have 1 potassium, 1 nitrogen, and 3 oxygens. Potassium is here. Its mass is 39.1. Nitrogen is here. Its mass is 14.0. And oxygen is here. Its mass is 16.0. So that comes out to be 48. Add these all up, and it comes out to be 101.1 grams per mole. Now, to get the percent by mass, we take the mass of each of the elements in the compound. So the total mass. So notice for oxygen, we're using 48 and not 16. We have to multiply it out. So of all the atoms there. So 39.1 divided by 101.1 times 100. That comes out to be 38.7%. The next one is 14.0 divided by 101.1 times 100. That comes out to be 13.8%. And the final one, 48.0 divided 101.1 times 100. That comes out to be 47.5%. Now, depending on how the question is worded, it might ask you the percent composition of just the oxygen, or percent composition of just the potassium. You have to pay attention to what the question is asking and make sure you're answering the question that's asked. So let's try another one. Let's do sulfuric acid. We have hydrogen, sulfur, and oxygen. Hydrogen is here. We have 2 of them. 1.0 is the mass. That comes out to be 2.0. Sulfur is here. We have 1 sulfur, and its mass is 32.1. So that comes out to be 32.1. And then oxygen, we have 4 oxygens, and the mass of oxygen is 16.0. So that comes out to be 64.0. We add these together to get the molar mass, and that molar mass is 98.1. So, depending on how the question's worded, I'm just going to go ahead and do the percentages for all of them. Although if the question is asking for a specific element, I would just do the specific element. So 2 divided by 98.1 times 100 comes out to be 2%. For sulfur, 32.1 divided by 101.1, oh, sorry, that was the last one, 98.1 times 100, that comes out to be 32.7. And finally, we have 64.0 divided by 98.1 times 100. So oxygen would make up 65.2% of the compound by mass. Alright, so what if the question was asking what the empirical formula was, and instead of having you determine the percentages, they give you the percentages. So here's the empirical formula that we're trying to figure out. There's a little rhyme that goes with it. Percent to mass, mass to mole, divide by small, multiply to whole. So all these percentages turn to grams. So percent to mass, we've done that now. Mass to mole. So we figure out the molar mass of each of these. So we have carbon is 12.0. Hydrogen is 1.0. And oxygen is 16.0. So percent to mass, mass to mole, that means we need to figure out we have to divide by the molar mass to get the moles. So 68.54 grams of carbon over 1, 12.0 grams per mole. So I'm going to divide by 12.0, and that comes out to be 5.71. The next one is hydrogen, 8.63 grams over 1. The molar mass of hydrogen is 1.0 grams per mole. That comes out to be 8.63 moles of hydrogen. I'm going to put carbon up there so we don't forget what we're talking about. 22.83 grams of oxygen now. 16.0 grams for every mole. That comes out to be 1.43 moles of oxygen. So percent to mass, mass to mole, divide by small. So we look at the three numbers and we determine which is the smallest. As we're looking at it, we see that 1.43 is the smallest. So we're going to divide all of them by 1.43. So this is obviously 1. 5.71 for the carbon comes out to be 4. And hydrogen comes out to be 6. So that becomes C4H6O1. Now it's very possible that you don't actually get nice whole numbers like this one did. If it's close, like 3.99 or 6.01, go ahead and round it off to the whole number. If it's more like a half, like if you get like 2.5 rather than 3 or 2, you're gonna want to multiply it by the reciprocal. So 1.5 is 1/2. So you multiply everything by 2. All right, so let's try that again. We have 4 of them this time: nitrogen, hydrogen, carbon, and oxygen. So 46.67 grams of nitrogen, 6.70 grams of hydrogen, 19.98 grams of carbon, and 26.65 grams of oxygen. So nitrogen first is 14.0. So 14.0 grams in 1 mole. 46.67 divided by 14.0 comes out to be 3.33 moles of nitrogen. Hydrogen, 1.0 grams per mole. So that's going to be 6.70 moles of hydrogen. Carbon is 12.0 grams per mole, so 12.0 grams, 1 mole. That comes out to be 1.665. And then finally, we have oxygen, which is 16.0. So 26.65 divided by 16 also comes out to be 1.665. So 1.665 is the smallest of all of them. So we're going to go ahead and divide everything by 1.665. Obviously the carbon and the oxygens are 1. 3.33 divided by 1.665 is equal to 2. And 6.70 divided by 1.665 is equal to 4. So that's N2H4C1O1. Alright, so when we're comparing the empirical formula and the molecular formula, so if it actually asks you what the molecular formula is, what you have to do is you have to figure out the mass of the empirical formula. So just like you would do the molar mass, just calculate the molar mass by looking at the periodic table. You have to determine the molecular. They are typically giving you the molecular mass, so you don't actually have to calculate that. What you need to do, however, is determine the ratio between the empirical and formula. It's going to be a whole number ratio. And then whatever number that comes out to be, you're going to multiply that formula. So if it comes out to be 2, and you originally had CH, that'd be C2H2. And you just multiply it out by that ratio. Alright, so let's look at some balancing. When I'm looking at this is all about the conservation of matter. Whatever we have at the beginning has to be there at the end. So, what I usually do is I make a list of all the substances we have. So I have sodium. I have a polyatomic ion here of phosphate. I have it on both sides, so I'm just going to leave it as PO4. It's just a little helpful cheating hint thing. Then K, and then OH. Once again, I have it on both sides. Alright, so Na, I have 3 at the beginning, and I only have 1 on the right. PO4, I have 1 PO4 on the left and 1 on the right. K, I have 1 on the left and 3 on the right. And OH, I have 1 and 1. So let's look at the sodiums. First, I have 3 here and 1 here, so I'm going to multiply that by 3. That changes that OH to 3. PO4, I have 1 and 1. K, I have 1 K here and 3 here. So I'm going to multiply the left side by 3. That actually ends up changing my OH to also being 3, which then ends up balancing the OHs out. And that's all there is. If there's a blank, that's automatically a 1. Don't get fooled by that. Let's try another one. P and O. I have 4 phosphorus and 2 phosphorus. I have 2 oxygens and 3 oxygens. So I have 4 and 2. So that means I can multiply the right hand side by 2 to change that to a 4. That then changes this to a 6. So that means I need 3 O2s in order for that to balance out. And now our equation's balanced. N and H, I have 2 and 1 for nitrogen and 2 and 3 for hydrogens. So if I multiply the right hand side by 2, that changes my nitrogens to 2. It also changes my hydrogens to 6. Now, in order to balance that out, I need 3 hydrogens on the left, and I'm all balanced. Don't be afraid to go back and forth because sometimes they're not always obvious. So let's take a second to look at the types of reactions. We have combination. So that means we have 2 things, 2 or more things coming together to be 1. So if you see one thing on the right, that means you have combination. The opposite of that is decomposition. You'll have one thing on the left. But combination is one thing on the right. Single displacement, that's when you have an element and a compound and something's getting removed. Like for instance, now we have AC and now B is all by itself. So you have an element and a compound and an element in a compound on both sides. Double replacement is if we have 2 compounds and then they switch places. So then A is with D, and B is now with C. So these two came together, and these two came together. But notice that they switched partners here. Know your solubility rules and know how to follow them, because the precipitation reactions occur with that. So if a solid is formed, it's going to fall out of the solution. Also, make sure you know net ionic equations and what spectator ions are. So let's take a look at net ionic equations. Whenever you see an AQ, that means it gets broken up. So we have 2 sodiums and 1 sulfide. Once again, AQ, so that means we're going to break it up. We have 2 hydrogens and 2 chlorines. Arrow, we have aqueous again, so now we have 2 sodiums and 2 chlorines. And then you notice the gas here. Because it actually forms something, we don't break that up. We keep that together. So let's take a look at spectator ions and net ionic equations. Spectator ions are the things that you'll see identical from one side to the other. So we have Na on the right. When we find Na on the left, that's going to be a spectator ion. We have chlorine on the left. We'll have chlorine on the right here. So that means that that's a spectator ion. So once we cancel all those stuff out, what we have left is what goes into the net ionic equation. So that's in gas form, and these were originally in aqueous. And that is your net ionic equation. Let's try that again. Whenever you see AQ, you're going to break it up. So H plus and NO3 minus. Those are both AQs. K plus and OH minus. AQ again. K plus AQ, NO3 minus AQ, and then notice the L here. That means we do not break it up. H2O stays together. So we're looking at things that are the same on one side to the other. So we have NO3 here. So NO3 gets crossed out. We have K here. So that gets crossed out. So what we have left is H plus and OH minus, yielding H2O liquid. And that is your net ionic equation. Alright, so the other types of reactions, we have decomposition. So that means we have we have one thing on the left, and then it gets broken down into different things on the right. So, if you have only one thing on the left, it's decomposition. If you have one thing on the right, it's combination. Combustion is some carbon compound sometimes it'll have Y, or sometimes it'll have oxygen in there, reacting with oxygen, and it'll always produce CO2 and H2O. So if you have something that has CO2 and H2O on the right hand side, you automatically know you have a combustion. And then finally we have oxidation reduction. Those are also called redox reactions. And it's actually referring to the electrons in the individual atoms. And we're going to take a minute to talk about those in a little bit. Acid-base neutralization. That's when we have, let's say, any kind of an acid with a base is always going to produce some kind of a salt. So an ionic compound. Remember, salt is just another word for an ionic compound. And water. And then gas formation is just another one where a gas is actually given off. And we actually did a net ionic equation when a gas was given off. Alright, so let's talk about redox for a little bit. Don't forget Leo-Gur. Lose electrons oxidized, gain electrons reduced. So if it loses electrons, that means it's oxidized. If it gains electrons, that means it's reduced. I am a very visual person, and so I like to look at a number line. So we can take these two and pair them up. There's supposed to be an arrow between them. So we have Hg2 plus going to Hg2, which is 0 now. So if I look at the number line, here's 0. We're starting off at a +2. And we're going to 0, which means we're going to the left of the number line. Which means it's becoming more negative, which means it's gaining electrons. That means gain electrons reduced. That means the mercury is being reduced. If we look at the iron on the number line, it's starting off at 0, and it's going to a +3. It's going to the right. That means it's losing electrons. It's becoming less negative. So lose electrons, oxidize. That means that iron is being oxidized. One last one. Let's try As. It's starting off at 0. This here, if you uncross it, means that that's going to a +3. So 1, 2, 3 is going to the right, which means it's becoming less negative, which means it's losing electrons. So lose electrons, oxidized. Chlorine, however, is starting off at 0 and becoming more negative as it goes to -1. It's going to the left. It's becoming more negative, which means it's gaining electrons. Gain electrons reduced. So if we were to match these up, the As was losing electrons, so that means it's oxidized, and the Cl is gaining electrons, which means it's being reduced. And I hope you found these videos as helpful as you can.